I forgot to record. Sorry.
Whoops.
Whoops.
Uh,
Gigastone. Yeah? I should make a list of the things that work and don't work, so that other people have a reference to if they get them.
oh, can't find my other ones. No.
And the
Um,
Gigastone is what size? Do you remember?
this one is 2 GB.
2 GB. Okay. And another issue I want to talk about the safe pills. I just want to check with you all, what safe pills versions do you have? Because I found out that 1.25 has issues with higher counts. If it's more than three micro seepers, it goes clunk, it stops, and we're getting new boards for that. I'm going to replace them.
Hello, everyone.
Hello,
Hey.
Hello.
you made it. Good.
Yeah, sorry, I forgot forgot the
No,
time.
You're
you're
not
not
the
the
only
only
one.
one.
Okay.
We all forget the time. That's good.
Well, here it's Sunday morning and you know,
Yes, Sunday mornings are like that.
But yeah,
Uh,
FS Pulse 1.25.
1.25. Oh, okay. I will send you a new one because if you go to the higher count, they're not good.
All right.
I have a whole list of people I have to send them to because I think we sent out about 20 of them.
Oh,
So they need to be replaced. And I'm fixing them now. Finally I got a microscope and SMD soldering tools so I can change the components on them.
nice.
It
so
works good.
those are the tweezers that you were talking about?
Yeah, also, yeah,
Yeah, okay.
the tweezers and the flux and the removal of the conformal coating stuff.
Oh, yeah.
Yes.
Right. Yeah, that stuff no, it's not meant to be taken off. Anyway, yeah.
No, but
So
luckily it's
I'll
acrylic.
true. Okay, so you can dissolve it, yeah.
Can dissolve it in acetone. It's like
Um I
basically nail
haven't
polish. Yeah.
I'll have a look at the one that's in the Zen that you sent me. The one I'm still
Yes.
building.
That's
So,
probably 1.25. That's the latest one
okay.
I sent to you. So I will send you a replacement
Yeah.
for you too.
So what was the problem? Is that the inductor just didn't have the same
No, no, no. There are many more. There are 4 or 5 components are different, and the
oh wow.
filtering in the beginning is too strong to avoid the double pulsing coming in, and so the values were changed by Alan, and Peter was supposed to have checked it, but Peter couldn't make the time for it to check it. So finally, last week, I got a good alpha source we talked about. And then I
Right.
started checking and said, oops, that doesn't work for those models.
Okay. Hmm.
So I have to send you one. And Michael, which version do you have? Do you know?
I'll go check right now. I'll just go get it.
I think Michael has a 1.2, I think. And I saw your work from Louis, from what you've been working on for the count and together with Colin. I mean,
Yeah, that was Callan's comments were really helpful.
oh, yes.
Because
Like,
basically when I started, I had no idea where I was going with this. And I'm not a mathematician, so I'm kind of struggling by guess and by gosh. Hello, Medved.
Hey,
Uh,
hello.
It's back.
And so basically, this is the theory. Okay, this
Mhm.
is a big fancy word. Is that if you have a sample that for 1 second, right? Let's say you have so many atoms in that sample in 1 second, so many of them are going to disintegrate,
Mhm.
right? That's a Becquerel, whatever, right? So if you cut up that time period into many, right? It so each time period represents one atom in the sample.
Mm.
And as you check each one, it's either going to disintegrate or live.
Mm.
So if let's say I have 10,000 in the sample, I can have 10,000. And at the end of 1 second, the idea should be the same.
Mm.
That's the theory. That needs to be checked out. And that's where Callan was pointing me is like, okay, do some serious simulation, compare it to the actual, Poisson distribution, that the
Okay.
curve, maybe the normal distribution, but not only for uh, number of counts per second over a long-term average, but also arrival time, right?
Mhm.
And I believe that's exponential. So basically compare those to um, normalized curves and then see, like how much error or deviation there is. And if it's a if it's a close fit over a large number, then maybe. But for small numbers, then also compare it to the binomial distribution. Yeah, like I say, I'm no math. I'm not a mathematician, so but it's proven to be a little bit of a tangent. I mean, at first, all I was doing is like, let's generate some pulses so I can get some counts out of my Zen when I'm working on firmware.
Mm.
Now it's just kind of things, I don't know, kind of got
Take off.
sidetracked.
But I was wondering, did you find already a good transistor for the for
No,
simulating the clocks?
I haven't looked at that. Let's one step at a time. But yeah, it'd be interesting and just start
I
basically
guess
cruising DigiKey and see what they have.
I can send you the ones I used for a 5,000 volt pulse generator. You'll
Woohoo!
be interested. Very good ones. I mean, and very
Uh,
short times for closing and stopping. So you can make very sharp
what
pulses.
what are they? Are they silicon carbide
Yeah, I think
or
silicon carbon. Yes, I
okay,
think so.
cool. Yeah,
They called
5,000 volts. It has to be. Otherwise,
they go conf
yeah. Otherwise, a high voltage SCR, right? And just
You can do
basically
that too,
trigger it.
but I don't know the speed of how fast they close and how fast they open. So,
True. I have checked that out.
mm,
So, um, okay, yeah, we'll look at that.
okay.
Well, if I have the 1.25, then I guess you're sending me the next iteration of the
No, we go back first. I give you an older one that surely works, and
okay,
then we develop, and then we.
okay,
I have to test a lot before I send them out. I don't like this to
okay,
happen again.
yeah. Okay, so yeah, so 1.22. Okay, so if you're sending me one, then just throw the transistor in there.
Yeah,
Yeah,
that's good. I have a few, so
yeah.
I can send
So,
you.
yeah. I'll also see I mean, it's not like I need large quantities. I just need one.
You need. I give you two.
Woohoo!
If one blows up or something happens
Oh,
with them.
yeah, I can blow things up. Yeah, that's no problem. All
Normally,
right.
I'm the one blowing up things, but
Yeah.
that's true.
Okay. So yeah. So yeah. So that's. I mean, if you look at what I'm committing, if you can see where I'm going with that. Last night I couldn't sleep, so I generated 10 million pseudo-random numbers. Right? Basically using right now I have basically files 1,000, 10,000, 100,000, so on, up to 10 million. So I can reproduce the experiment, just basically keep
Okay,
using the same data file. So that's the reproducibility that Kellen was concerned with. So
that's good. That's a good start. Yep.
I have to
And
start somewhere.
also, did you
Yep.
look at the map from from Matthew?
No, I haven't.
So because that would be very useful if you can integrate that in for Canada. I mean, the
Yes.
Canada area, you can
Yeah.
use that instead of the map with Grafana
Yeah.
or other ways. So, or
Yeah.
your own map that you had. So,
Well, I'm just gonna keep using my own map because that's, I mean, it's a good start. It loads fast.
Hmm.
I know it. All I'm doing right now is got sidetracked. Where it's stopping is the JavaScript to load a new, like, register a new device on the map, and also hide it, as well as setting up all the alerts, right? Because that's going to go through email,
true.
right? And so that basically,
Mhm.
I'm not at all familiar with JavaScript, so it's a learning experience, and that's probably why it's so slow.
If you need help, maybe Matthew can help you out.
Okay.
He knows it quite well, I think.
Yeah.
Yeah. Okay. Yeah, sure.
Yeah. Or maybe even if you have the real-time sensors and then the data from other people around it also as a layer, that will be good too. So
Yeah.
you see what's real-time and what's recorded from other people before.
Right. Yeah. So I'm just going to keep using the TT serve, right? Just pulling data from that.
Yeah. Yeah, that's fine. Yeah, that should work.
Yeah. Okay.
Okay,
I think
good.
that's it for me for today.
Yeah. Kind of for me too. I mean, the safe pulse is taking all my time away and studying and doing that and also trying to get the sales up for the bGeigieZen. But we will have a winter discount coming up, and we're designing the logos and other things for that. But it's going to be winter in the northern hemisphere, but summer in the south. So it's not only winter sales; it's winter and summer sales.
That's why you have people in Australia going on to
Yeah.
the beach wearing Santa Claus hats. Yes.
Yes, that's true. That's true. Yeah. Okay. Matthew, you
Sorry,
had
guys.
something?
And one question that occurred to me during this period was why we are using, what type of measurement unit we are using, sieverts or Rentgens. Have you thought of this, the matter of sieverts and the matter of Rentgens or CPS? Uh, because my wife, she's far away from radioactivity, but she says, why don't we check temperature in the way that sieverts are measured? It's relative to the person who absorbs this temperature. And I thought, why the hell on earth we are using this sievert? Maybe not the hell on earth, but some. I did not get the idea. Have you think about that or not? Rentgens is the emitted radioactivity, and sieverts, as I understood, is absorbed radioactivity. And absorbed is giving us several variables or some abstract variables that are absolutely non-understandable.
No, I don't have any idea about why people use sieverts and why.
I even thought that the sieverts was some kind of a joke about the person who was fighting about maybe contamination of the radioactivity. And this measurement is somewhat more difficult to understand for people, and it was introduced just some kind of maybe.
The way I understand it, if you want, I'll take a shot at it.
Mhm.
So, what the Zen and the Nano measure normally is counts per minute, and that's
Yes, CPS.
that's
That's
per
absolutely
minute,
understood.
CPM minute, 60
CPS
seconds.
minute, I
So we
understood.
average over 60 seconds.
Mhm.
That gets multiplied by a constant that's based on the absorption of radiation from cesium-137,
Mhm.
and that gets translated to the dose, the equivalent dose that a human would get. So it's very arbitrary, but
Mhm.
but everybody uses roughly the same, right? The cesium-137 constant to go from counts per minute
Mhm.
to a dose. And that's, let's say if you're a radiation worker, you're a nuclear worker, that would be your little badge, right? It would also give you sieverts. Um, in survey mode, the Zen switches to a 5-second average, and it's meant to hold the Zen or the Nano over the surface, right? To see what was deposited there, right? Obviously, in the case of Fukushima, that was a very important question: is what is the ground level, right? What is the dust at the ground level emitting? And the measure there is becquerels per square meter. So, in other words, you can see how much is there on, per surface area. So that,
Mhm.
as far as I know, but that's the idea of the becquerel. So. I'm not too sure what the metric unit equivalent to Röntgen.
Welcome. Good afternoon.
So becquerels is
Morning,
the
where you're coming from.
it's the number of
Yes, I understand this. This is the absolutely normal
Then
behavior, but
you
I asked myself why do we use that, and I did not came to any
okay. Well,
conclusion.
now you're going back into the history books.
Yes, it's some kind of what is emitted is understandable, but what is absorbed is very relative to the if you are in the bikini or in good alpine clothes
Yeah,
that you are climbing the Everest.
yeah. Well, yeah, yeah. I think again, you'd have to go look at the history books. I think my guess is one of the reasons they chose cesium-137 is that's the most common uh, radioisotope that would come out of a fission plant accident.
Understood.
So, yeah, I mean,
Okay.
if you look at the evolution of of something like Fukushima or 3 Mile Island, first out comes the iodine as a gas, followed by cesium as a fine dust.
Mhm.
So, and whatever else,
I thought can we with our team of this safe cast members can we change this behavior and uh, mm, for example introduce our own vision in some time or if this
No.
idea is broken,
There's too
I
many.
maybe
think
the first idea is broken, I believe.
Well, like go ahead and try, but I don't. I think there's so many units, measurements. Like there's the 3 types of radiation uh, that where just the distance or the shielding material, as you say, it matters. Um, Basically, like why in the U.S. and British units, why is a foot a foot? Well, that was the size of the king's foot at one time. Good enough. Now we have a unit of measure. History.
But foot is absolutely understandable measure. It can be translated and it has no unknown variables. But
Yeah.
observed the measurement, it has a lot of unknown variables actually.
I agree, and that's where it gets complicated. Just start the if you look at Kellen's GitHub, um, he has a huge list of resources on nuclear technology and radiation measurement. So start digging into there. So it's
Mhm. Thank you.
Or
Okay.
or maybe ask Helen directly. You can do that too. Ask the
Yeah,
same
yeah.
question, Matthew.
Yes.
So maybe you get
Yeah.
an answer.
Yeah.
Mhm.
I don't think we're going to be setting any standards here. We're just
No.
Our new standard,
I think you're trying to get invited to
just
one of
a
those
common sense standard.
yeah. I think you're trying to get yourself invited to one of those conferences where they have a lot of dinners.
That's
Understood.
true. Yeah. Okay.
Okay.
We have other things to discuss? Or-
Nope.
And
Yeah, I have
and
one more question for
Yeah.
you, Rob. Is your branch that you're working on the what was the
The battery links.
battery?
Yeah.
Let's see. Where is it?
Battery
Oh.
something. Logging battery or something.
Yeah, but battery logging working. Is that like close to ready to be merged to development?
Oh yes. Yes,
I
please.
just
Please do what you please what you think
okay.
is necessary. Yeah. I can branch off
Well,
again.
you can
No, I
merge your
prefer
own
you
branch
I
or
prefer you do that.
oh God. No, okay. If you can make a pull request on GitHub
Okay.
for the branch to development, and then I can press merge
But okay,
after
good. You can check.
reviewing maybe.
Yeah, I prefer you review it because I don't trust my own code, so I better have somebody look over it.
Yeah, I might do some changes on that and then merge it.
Please do.
But I don't want to work too much on a different feature in that same branch. So
Okay.
uh,
No, that's fine. I
all
will
right.
do that.
Okay.
All right.
That's it for me then.
Yeah. Michael
and
has
what
something. Yeah.
SDK, no, this hardware kits. If for example, I'm also interested in developing these devices.
I didn't understand your question or talk. One more time.
Understood. Where to get these SDKs for development? If I'm also interested in development.
Oh, it's all on GitHub too. I can send you a link. I mean, bGeigieZen. If you check GitHub bGeigieZen, you can find out.
And hardware devices, at least this sensor.
Oh, the sensor
Well,
is from
you need at
LMD.
least the M5. Yeah, this is the M5 stack, so you can order it online. That's basically all you need for development.
And this sensor,
The
Gigi.
tube itself. The tube itself is LMD. You can order it online too.
Understood.
They are not cheap. They are about $130.
If you want to join development, I recommend just getting the
Get this one.
M5 stack. And then let's see, Lewis has created the Geiger simulator, or the pulse generator, and Michael had created a GPS simulator. So you can basically, if you have some Arduinos or some cheaper microcontrollers, you can connect them to the M5 stack, and they will basically function as if you had a Zen.
We have